Good morning, good afternoon, good evening. My name is Peter Marshall. I'm a technology evangelist at Imply, and I offer all you Druids across the world a very warm welcome to this fourth talk of the day at this second Druid Summit. There are over 800 people registered today to hear from the Apache Druid community across the world. All attendees, you'll be on mute throughout the session, but that doesn't mean you can't ask any questions. Please use the Q&A section of the Zoom webinar panel, and we will pick those up at the end of the presentation. If there's any that we don't have time to answer today, we will respond in a follow-up blog post, and links to the full presentation and the accompanying slide decks will be sent following the session. There'll be live tweeting throughout, so be sure to follow us on Twitter. Many thanks to those people who've already spoken today. We just heard from Jeremy at Target. We started the summit with the Apache Druid Committee Chair, Gian, and followed that with a great talk from Traffic Guard's Rai Gonjoli. Here with our fourth session with Nicholas Ungarok. Nicholas is engineering manager at Twitch, leading the data infrastructure team. He's responsible for building and maintaining Twitch's data platform, building tooling and services to ingest, store, and transform their data. Welcome, Nicholas. I can't wait to hear more about your self-service analytics adventure with Apache Druid at Twitch. So enough from me, over to you.
Thank you, Peter, and thanks everyone for tuning in. I'm Nicholas, and I'm going to talk about self-service analytics at Twitch. So to start us off, what is Twitch for those unfamiliar with Twitch? So Twitch is where millions of people come together live every day to chat, interact, and make their own entertainment together. Twitch is really about the community and what creators streaming on the platform are able to do together with the community, whether this is playing video games, cooking, or eating together, creating music together. It's really a great selling point and something that's amazing about Twitch. This really shows up in the number of people that use Twitch. So we get over 4 million unique creators streaming every month, and about 17.5 million average daily visitors from everything in gaming to music to talk shows. Now a little bit about my team. So as Peter said earlier, I lead the data infrastructure team at Twitch. We develop and operate a data platform, which is used to power data systems and decision-making at Twitch, receiving over 80 billion events a day. And the tooling we provide helps folks ingest, store, transform, move, and understand the data they're using. So some of the technologies we use are highlighted here, although they're only a subset of everything we're using. So our data lake is on Amazon S3, and we use Redshift via Redshift Spectrum to query it. Kinesis powers a lot of our real-time streaming, and we use Apache Spark and obviously Apache Druid, which I'm talking about more in this talk. So for this talk, I'm going to start off by talking about the challenges we were facing and why we required self-service. Then I'll go into why we chose Druid and Imply's pivot product to help us achieve that goal. I'll drill into the details about how the system all works, and then I will cap off with what comes next and how do we want to make it even better. So let's start off talking about self-service and why we needed self-service at Twitch. So as I said earlier, one of our team's tenets is we really want to empower decision-making at Twitch via data. Data is a very critical part of all decision-making around the company, and we wanted to empower everyone at the company to be able to make appropriate decisions backed up by data in their day-to-day. And to think about it, we can bucket employees and staff at Twitch into two personas. The data staff are folks whose day-to-day is writing SQL, using BI tools. They live and breathe the data at the company, and they know where to find the data they care about and what queries to write. Non-data staff, on the other hand, would like to use data to make their decisions, but they don't spend their day-to-day writing queries or using BI tools. But we want to empower them all. So this is what the flow looked like initially. So for non-data stuff, such as product managers or business leaders of the company, when they wanted to find what data they could use towards making a decision, they would first think about what data exactly do they need. Then they would have to place this request with someone from the data staff who would figure out where is this data, what format are they going to present it back to the requester, and then send it back. The requester would look at the results, analyze the data, and hopefully make a decision. Often at times, what would happen is when you get back the data that you've asked for, you find that you have more questions to ask. And so you repeat the cycle till you feel like you have adequate data and you can make a final decision. Now, data staff flow is a bit similar, but given their knowledge about where data lives at the company and their ability to write queries and use BI tools, they identify required data or collect the requirements from non-data staff and translate them, figure out where exactly data lives. This might be looking at the documentation or talking to other analysts at the company that own the data, and then write the appropriate queries and decide on the presentation format, whether it's tabular or it's graphical in some way. And if it's for their own needs, they would analyze the data to come to a decision, or they would give the data back to a non-data stuff. An example I can think about is an analyst at the company that wants to predict site traffic and build a model to predict site traffic so that can empower the scaling up or down of infrastructure at the company. So they would identify where is the data stored about the site traffic we've had thus far, write the appropriate queries, and use that to create the model they care about. So let's walk through an example of this. I'd like to introduce to you Alice and Bob. Alice is a product manager at Twitch for the subscriptions product, and Bob is a data analyst at Twitch. For those unfamiliar with subscriptions, they are one of the ways in which you as a viewer can show your support for a creator on Twitch. So for example, you could subscribe to a creator you like's channel for a certain amount on a monthly basis, and part of that would go towards supporting them financially. So in this scenario, Alice would like to really improve the subscription product at Twitch, and he's asking a couple questions to find the data. So she would start off by asking Bob. So I would like to know all the subscriptions in the US over the past year. Bob will go through the data staff flow, identify the data, figure out how to represent it, give it back to Alice. Having gotten these results, it piques Alice's curiosity. And so she has a follow-up question for Bob's, which is, what about over the past 5 years? What does this data look like? Bob goes through the same flow, gives the data back to Alice. Alice yet again has another question, and that's like, does this look any differently in some other countries? In this case, the UK, South Korea, and Brazil. Finally, getting this data back, Alice is able to analyze it and has a bright idea about how to improve the subscription product. Now, these flows, as you've seen, have a couple of challenges that were presented to both non-data stuff and data stuff. For non-data stuff, such as Alice in this example, you can see it takes her a really long time to get to results because there's back and forth she has to go with Bob. She's highly dependent on Bob to get her the data that she needs. And depending on which analyst or data staff she uses, she might get a different view into the data. So for instance, let's say initially she got a table, and then the second time she gets a pie chart, and she would have to try and understand the differences between the data and interpret them. On the other end, data stuff such as Bob have additional work that they have to do because they're helping fulfill requests coming from non-data stuff. They need to spend quite some time figuring out where is the data, what do the columns in the data mean, whether it's looking through documentation or talking to other people. And then they also need to be very good at translating requests from non-data staff and presenting the data back in an acceptable format. And a big issue that was happening at the time is different data stuff could get different results and give inconsistent results to non-data stuff or to others at the company because of all the different tables that exist and the different interpretations folks have of the data. So those were the challenges we were initially facing, and here's why we went with Druid and Imply Pivot to solve them. So just a quick recap. Based on the challenges we saw, some of the requirements that we had were we wanted a unified and consistent user interface that everyone was using and had such that everyone would have the same view into data. We wanted it to be self-serve so that non-data staff wouldn't have to be reliant on data staff. We wanted reproducible and shareable results. Fast query speed was important to be able to get to decisions quicker. And we also wanted to create trusted aggregate data that had ownership at the company to help deal with the data inconsistencies that I spoke to earlier. So how does this work in Druid? Let's start by talking about what the scale of our cluster currently looks like. We process 8.5 billion real-time events, which is about 1.3 terabytes a day. We ingest 5.6 gigabytes of batch events, have 50 data sources, use about 80 terabytes of cluster storage, and have 450 monthly active users of Pivot, which results in about 70,000 queries per day. The reason we have both batch events and real-time events are events that are, well, real-time coming in, but batch events are the trusted aggregates, which I spoke to earlier. So they're curated data sets that data stuff create such that we have sources of truth for cubes that we really care about at the company. So architecturally, this is how things are set up. We follow the recommendations by Druid where you split your cluster master, data, and query. Our overload and coordinator are in the same server. We split our middle managers into real-time servers and batch servers because of the large number of requests, the large number of events we ingest that I showed earlier. Our batch middle managers are typically low. However, when we create a new data source and are backfilling it, we increase them to help with the ingest. Our historical nodes are their own servers as well, and we use the same server to host both Pivot and our brokers. Now, in terms of our deployment, we do blue-green deployments and use that for updating Druid, except for historical nodes where we run Ansible and we'll stop the service, do an upgrade or perform the operation we care about, and then start it running again. So in terms of deployment, we are deployed in AWS. Our historical nodes are i3s. Our middle managers are R5s. Our master is a C5, and our brokers are R5s. So here's what the flow looks like. For real-time ingest, a member of the data stuff goes through these steps to actually get data into our Druid cluster such that it shows up in Pivot. They start by speccing and creating a data cube. So they think about what are the measures and dimensions that they would like in this cube, write those down, create it, backfill a little bit of the test data, and then validate if this looks good. Then they set up streaming. In this case, we use Kinesis, so our real-time events will keep flowing into the cluster, and it's important that they set this up before publishing it, and then backfill data back as far as they would like for the cube. Verify the output looks correct on our Pivot, and then publish it. Part of publishing includes saying who has access to this data at Twitch. So if we go back to Alice's example before, you can think of subscriptions as a real-time event at the company, whereby as subscriptions happen, events are getting published into our pipeline. And so if we want this to show up in Druid, we'd create a cube specced out with the same dimensions as the event and go through this flow to actually make it show up in our Druid cluster. So what does batch ingest look like? Batch ingest is somewhat similar to real-time ingest, except there's a lot more work that data stuff do to create what are the trusted data sources of the company. So initially they spec and create the data cube. This is more work than the real-time where it's a one-to-one translation. When creating a batch cube, data analysts identify the data they care about, which can come from multiple tables at the company. And then they use an in-house SQL ETL framework that we have to create DAGs that help generate the data that would be going into this cube, which is output into S3. So this can range from a cube can go as big to, say, a cube that has over 50 dimensions and over 50 measures, as an example. Once they have that in place, they can backfill some of the test data, validate that the cube looks appropriate on the pivot side, and then go through the same flow. The only difference now is they're not setting up a real-time stream. So they would start by backfilling and verifying some of the data, and then they would set up a recurring backfill. So we run our backfills on a daily basis. And then they would publish it and make it available to everyone at the company or a subset of users that they care about. So how does this work, and what tooling have we set up to enable folks at Twitch to do this? So a very important thing for us whilst we were building this out was, in as much as we were powering self-service for data stuff whilst they looked at the data, my team also wanted to empower the data stuff creating cubes to be able to self-serve the cube creation. And so this is some of the flows that were put together to make this work. So data sources or your data cubes are stored in a Git repository. So when creating a new data source, a member of our data stuff goes into the repo, writes their dimensions and measures into a JSON file, goes through a code review process, and merges their code. This triggers a Jenkins job, which will upload the changes as well as other scripts that live in that repo into an Airflow server that we run. And the Airflow server we have runs a couple of jobs to make this possible. For starters, there is an hourly job that is run, which will check for changes to specs. And then this will trigger this will trigger a script which runs and kills any supervisors that were ingesting specs that have been deleted, or creates new supervisors for new data cubes that have been added. So this is what happens when a new cube is created, and you're either backfilling it or you're continuing to ingest it. This flow will automatically trigger that, or you can manually run the script in order to kick it off for you. Additionally, there exists a backfill script, which you can use to specify how far back you'd like to backfill data. So this is a script that's often triggered by our data stuff when they're first creating their cube. And this kicks off an Airflow job, which does our batch ingest by running a Spark cluster in EMR that will extract our files from our data lake and convert them into JSON with appropriate segmentation for ingestion into our Druid cluster. The last part of the flow is for real-time streams. Our data staff can also set it up using some of the tooling we have. We have a kinesis configs script, which essentially takes the commit from Git, looks at the cube spec, figures out if the cube is real time, and then will output the kinesis configs that one needs to change to ask to get our data pipeline to forward events to a kinesis stream, which our Druid cluster would be ingesting. And we also have an in-house schema service that allows our data staff to use a UI to actually input these kinesis configs and make everything happen almost automatically for them. So with this all together, let's go back to Alice and see how has this changed what life looks like for Alice and for data stuff at Twitch and the company. So if you remember from my initial example, Alice and Bob, Alice was a product manager and Bob was a data staff. Now, given that we're using Pivot and Druid as our data store, what really changes for Alice is, well, she doesn't need Bob anymore. She's got Pivot now. And she's able to self-service her queries. So initially, Alice wanted to know all the subscriptions over the past year in the US looked like. And she would ask Bob to go find the data and curate it and present it back to her so that she could hopefully make a decision. What changes with this flow right now is Alice will instead get in Pivot, go to the subscriptions cube that has been created in the flow that we have, and then she will basically just filter the cube by filtering. She'll filter the country dimension specifically for the US, and she'll look at the data over the past year without interacting with anyone else. And her curiosity is piqued looking at this data. And so for the next step, she would like to see what the data looks like over the past 5 years. So instead of having to make another request to Bob, she instead just makes a change on how much time the cube is covering on Pivot and switches to the next 5 years and is able to look at the data right away. Curiosity is piqued again. Now she would like to see it over the US, the UK, Brazil, and South Korea. She no longer needs to ask Bob to look at this and just only has to update the country dimension filter she previously used to be not only for the US, but to include the US, the UK, Brazil, and South Korea. And with that, she can finally see the data and once again come to the bright idea she had previously about what the right way to improve the subscription product at Twitch would be. So if we bring this all together and thinking back to the requirements we kind of had going into this and the massive changes we see in Alice's flow, these were the benefits that we saw Pivot, implies Pivot backed by Druid gave us. We get a consistent user interface via Pivot. So all our cubes use the same UI, and so we're able to get familiarity with it amongst all data stuff and non-data stuff at Twitch. We are able to provide trainings to different people at the company so that they're able to build familiarity and get well-versed with using the user interface. We have really fast query times. Our P98 of queries take about 500 milliseconds. Pivot also gives us the ability to create shareable links such that any cubes we're interacting with or any dashboards we have can be shared with anyone at the company. So for instance, let's say Alice is looking at different cubes and find something that's really interesting, applies certain filters. She's able to generate a link and share with other product managers or other members of her team at the company so they can all look at the exact same data and use that to power their discussions or the decision making. She can also use the links in a report per se, which is like, here's how I'm going to improve the product, and here are links to actually look at the data if you'd like to drill into it yourself. Additionally, we're able to create dashboards, which can be shared with everyone at the company that has cubes or representations we care about. And I think one of the very powerful features that Pivot gives is all the tooling available to do data exploration. So looking at the simple example I gave previously, Alice is using mainly filters. So lots of filters can be done on dimensions or measures we care about. Pivot provides multiple visualizations for our users, whether that is tabular, whether it's a heat map, whether it's a bubble chart, whether it's a histogram, or lots of other graphs. So you can look at the data in whichever presentation you prefer, and you have the ability to do that yourself. You can also highlight and zoom into a specific area within a graph that you care about. Basically, just in general, the ability to do this self-service really empowers our users. Additionally, with the flow that I talked about earlier, the fact that we have Git for describing our data sources means that we are able to enforce cube ownership. And we're also able to govern sort of like changes made to data cubes, because that goes through our code review process. Last but not least, an important thing that gets us is we now have a trusted data store for our aggregates, which are showing up in our Druid cluster, and making changes to that requires going through that floor. So we're able to govern and sort of control the quality of the data that is on Druid and folks are able to see at the company. So what exactly is next for us? The self-serve so far has been highly successful. Adoption is really good at the company. As I say, 450 monthly active users is about a quarter of the company using Druid. There's still work for us to do in terms of getting even more folks at the company to use it. But for my team, the two main things we are interested in is, the first thing we'd like to do is simplify cube creation even more. As I showed you in an earlier slide, the flow right now is a little bit complex. We've got scripts, we've got an Airflow server, which our staff need to SSH into from time to time. We have the internal schema service, and so it's a lot of things that our data staff need to know in order to create cubes. And what this creates is that the ramp up period for anyone new coming into this flow can be quite high. So what we'd like to do is continuously simplify this process for folks. And we also want to expand the coverage of data sources. Given the great reception we've gotten to using Pivot and Druid at the company, we want to increase the number of data sources as well as the size of some of our other data sources, increasing the number of dimensions and measures that we have. So that's it. Thank you for listening to my talk. As always, if these challenges sound interesting to you and you're interested in Twitch as a company, please feel free to reach out to me on LinkedIn. I'm hiring at the moment, and we are hiring in general at Twitch. So please feel free to throw me a line. And thank you all for tuning in. And also, I want to really thank my team, as well as the data staff at Twitch that create and continue to own the cubes. Like this self-service endeavor would not have been possible without everything that they've done to make it successful. So thank you all, and now I'll take questions.
Thank you, Nicholas. That was awesome. Thank you very much. And not just a thank you from the UK, but a thank you from Germany as well, just for you. So Europe is listening, Nicholas. You haven't got rid
Vielen
of us
Dank.
yet. And there's a question. Do you hire people in Europe, smiley face?
Not specifically for my team. I would say, however, there is a Twitch office in Europe, in the UK. And so,
well, I'm all right then, Nicholas. But yeah, I wasn't asking for me, honest. I'm not asking for me. Okay, be serious, be serious. So I just want to say thank you because this socialization of data, this self-service analytical world. I mean, it's very foreign to some people. They get very afraid of it. You know, they think, well, what's going to happen if someone comes up with the same report twice? What happens if they're not using reliable data? What if they're coming up with different conclusions? And it sounds like you've really got it solidly at Twitch. So I'm very happy to hear what you said. And this Git to Jenkins to Airflow workflow, I mean, there's a book there, right? I'd love to hear more about that. So we might invite you back to talk about that in detail. You can tell us a bit more about that. Okay, so on to the questions that people have posted. Please keep posting them, as I've said. If there's any questions on here that we don't get to during this session, we will reply to them in follow-up blog posts. So there's one question about late arriving data. And if you have late arriving events coming into that Kinesis stream, how do you deal with the order of it? Do your users not care about that, or is that something that you have to deal with afterwards?
So I would say we can deal with it afterwards because of our backfilling script. So essentially, if there's any data that is incorrect in Druid, we can always come later, run our backfill script, and specify the period in which we want to backfill to actually correct it. So that's something we use from time to time to make such corrections.
Cool. Do you do any sort of auto scaling of the Druid cluster behind the scenes?
We do not. We have our clusters. Our servers are behind an ASG, and we essentially have a specification for our ASG, but that is the most that we do. Most of our scaling is manual, up and down.
So how are you doing capacity planning and things? How did you decide what size the cluster should be now and what it's going to look like in a few months' time?
Oh, yeah. So the way we do capacity planning is, so it's often clear, like we know what our data sources are, and we also know what data sources we're going to add. So we have a collaboration between my team and the data staff that are creating cubes at the company. And so when a new cube is going to be created, we're able to say, what's this going to look like? How much data would it look like? Will it be ingesting on a daily basis? And then we can project what this looks like when we backfill, say, the past 5 years and going into the next 5 years, and check if our cluster is appropriately scaled or if we need to make additional changes to it to be able to cope.
Cool. Thank you. So we have a couple of questions about the role that Spark has in your pipeline and how it connects to Druid. So, for example, are you pushing directly into Druid from Spark? And if so, how are you doing that? Are you using Spark streams? Are you doing real-time transformations? Those kind of questions. So tell us a little bit more about how Spark is playing the role there.
Sure. So we are doing, for our batch ingest, we're doing it via Hadoop. So there's a couple, two ways you can do it. You can do it via Hadoop, or I think either this year or last year, native ingest on Druid is a new way to do this that came up. So we're doing it via Hadoop, and that's where Spark comes in. And that's essentially taking Parquet files from our data lake and converting them into JSON, which is then getting ingested via the supervisors into Druid.
Right. So I've seen it where Spark is acting on the stream and then pushing it back into the stream again and then ingesting into Druid. I've seen that done. It came out at the Spark conference, actually. So I'm giving myself a job here to write a blog post on Spark integration, I think. What have I done? So I had a question about what your biggest challenges were with onboarding people into this new workflow, because it's quite a radically different workflow that people are having to follow. Did you have like big challenges bringing them on board?
Yeah, that's a really good question. I would say, in general, when you're changing the flow of people, you always run into challenges, right? Just in general. But I think there are a couple of things that we've done to try and make this easier. I think one of the big things, Serdara, who's in our Center Analytics team, like runs trainings for folks at the company about here's how to use Pivot, and he walks through some examples and really teaches folks how to use it. And I think that that's been a very successful thing we've done to onboard users to it. I think it's always easier when someone's showing you like, here's how you do this. It's actually not that hard, and then you are able to see the value you get out of it. So like a light bulb goes off in folks' minds when they're able to see, oh, here's this data I care about, and I can easily do it by a couple of clicks. So I would say getting people onboarding was a challenge, but using training has really helped get us up to 450 monthly active users.
So you've got people who we've all worked with who are quite happy with a brokered analytics service, if I put it that way. Are they beginning to adopt this kind of new way of working easily? These stragglers, if I put them that way?
Yeah.
I'm asking you tricky questions now, Nicholas, because they're things we all think of.
I would say yes. I think in general, people are able to see the value that we're getting out of this. Having trusted data sources is incredibly important for the company. I think that having to go and talk to, let's say, 5 different analysts when you care about a certain event and getting different responses and not being able to use the output because they can be contradictory. So going from that to, okay, I just look at this cube and I have my answer and I'm certain it is the correct answer because of all that's gone into making sure it's the right data, is such a huge shift that it's quite easy to get stragglers on board when they see that paradigm shift.
Yeah. So I love the mention that you had of how the people's conclusions are socialized. You end up with a body of people who are working together to create this kind of confidence that their results are correct and it's not hidden away in some kind of thing they're circulating on a portal somewhere on some kind of email system. They're kind of building this culture of quality of data analysis in the group. Like, it becomes like a herd thing that they're all enjoying this thing together or getting excited about it together and they're all driving towards the same thing. It's a very different way of behaving, isn't it? So I'm well happy. I'm very glad you're talking about it. Okay, so we had another question, which was about this DevOps pipeline. Are you thinking about open sourcing it, or is there any more kind of documentation around it that people can read more about how it works?
So the DevOps pipeline, I guess that is referring to the Git workflow. Yes. And Jenkins. And unfortunately, right now, we do not have this open sourced. But this question is probably good incentive for I think us to, I think you alluded to it earlier, Peter, that perhaps a follow-up talking about what that actually looks like in depth, or perhaps something in writing we can put out would be a good idea, because that really seems to have piqued folks' interest.
Yeah, for sure. It's like, how do I glue all these bits in the big data zoo together and make this thing work? Yeah. Well, I'll be hassling you for that, Nicholas, for sure. um, I think we might have covered it, but one of the questions is just how big is the cluster as it stands right now?
So it's, I would say, medium size. To give an example, I think we've got about 36 historical nodes, if that gives you a sense of the size of the cluster. As I showed earlier, we're using 80 terabytes of cluster storage, but that's about half of the actual storage we have available
Right.
based on
Because
our
you had a
instances.
mix of i3s. I think you had some R5s in there, I think, if I remember rightly. How did
Yes.
you make a decision about what kind of machine you should be using and which role on AWS?
So I would say we followed. So Druid has a good recommendation, and I think Imply talks about this recommendation when they're talking with you about what a good deployment looks like. And in general, when you're thinking about your historical nodes, you're going with the i3s because of the SSDs, right? So you're
Right, right.
optimizing for disk, while for your middle managers, you're optimizing for memory, which is why you have R5s. And then on your master, you are optimizing for compute, right? Which is why we have the C5. So I think we just followed the recommendations, and that's kind of worked for us thus far.
Cool. Yeah, I've seen some. There's some like best practice guides around on the web that I've seen. I think there's some on the Imply blog about different architectures as well. So maybe I'll circulate that when we conclude the session today. Um, one final question. I think we've got time for one more question. Oh, we've got a few more minutes. Do you, when you're combining the batch and streaming ingestion into Druid, is that going into the same data source? If it is, how are you coping with things like the segment locking and segment timeouts that happen when you're doing ingestion in both methods?
So they're separate data sources. We've got real-time data sources and batch data sources, and that's what allows us to have both real-time and batch middle managers. So we separate them, and we also think about their ingestion separately, and that allows us to scale quite well because the two can have enormous amounts of data.
Cool. Thank you. Couple more questions then. So again, it's about this adoption thing about promoting the use of the tool. Is there anything in particular that people are using, like specific strategies or specific methods that people are using to kind of promote that to other teams?
Um, so obviously there's the training, which I've talked about earlier. We have Slack channels where people are sharing data they've used, and usually
Oh,
when they do that, they will have a link saying like, this data looks really cool. Here's a link to our pivot instance so that you can see the data. So that's a good way people are sharing. Sometimes in presentations, you see charts and graphs which come from pivot that are used, and folks talk about it more at the company. So there's a mix of organic sharing that's happening, and there's also via presentation slash almost internal marketing of the tools that we
yeah,
did.
cool, cool. Um, so I have one more question for you. So it's an anonymous question. The uh, self-service analytics is great. It's fantastic. Get loads of people to look at their data. How are you dealing with the prospect of data leakage and security around that? What kind of functionality are you using in what you've got?
So I think in general our data is encrypted at rest. Um, so so we have data encrypted at rest, and then in terms of data ingestion, we're thinking about storing aggregates. So we have aggregated data, and I think when you use aggregate data, you're able to obfuscate away private information from folks. So that's something we get by taking the trusted aggregate approach.
Right, cool. And how is it being secured, like to the front end, to actual end users?
So we use LDAP for login. So our users have to log in, and different users also have, I think Druid gives you access controls, and so you can specify the roles different users have. Oh, sorry, I meant pivot. So different users have certain roles and access granted to them that they're able to do. So that's a feature we take full advantage of.
Cool. So that it's at the application layer is when you've got like the authorization mechanisms in front of Druid, and that's with the talk that we just had from Jeremy at Target as well, was talking about how they've implemented a similar thing in their APIs on top of Druid as well. Cool, thank you. One question that we've just had come up: are your dimensions stored in an encrypted form inside Druid? I'm guessing what we're asking there is about like the actual values, I guess. Sorry, Jeremy, if I'm getting your question wrong here.
No, but I think what the question is asking, and what I would think about where you'd want to do this per se is, let's say if you had private customer data going into your cluster, and so
Right.
Maybe you want to obfuscate away someone's user ID, for instance, and so you'd store the encrypted or hashed user ID instead. I think in general, because we're storing aggregates, we're able to sort of circumvent having to think about this. But I can see a world and a need to do so, right, depending on what your dimensions are.
Cool. Okay. Thank you very much. We're out of time. I'm a bad timekeeper. I'm going to get told off. But Nicholas, thank you so much. It was a really brilliant talk. Thank you so much. And thank you everybody for all your questions. As I mentioned earlier, the links to the slides and the recording will follow this presentation. And as always, we'd love to hear your story about using Druid. You can email us at community@imply.io. Share your own Druid stories and get the latest information about what's going on across the world in the community. Our final speaker for the day at the top of the hour in about 12 minutes is Ben Sykes. He's the senior software engineer at Netflix. His presentation entitled How Netflix Uses Druid in Real Time to Ensure a High Quality Streaming Experience is sure to be awesome. So I look forward to seeing you all there. Thank you very much. Thank you, Nicholas. Cheers, everybody.